Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have Howard Zuo. He's a co-founder of Dataland. Howard, maybe you can just give a quick intro.
Sure. Yeah. So Dataland is like a unified data platform for customer support teams. So basically, whenever you reach out to customer support, you chat in or you call someone and you say, hey, I have an issue with, like my shoes not arriving on time or something. The person on the other end of that call has to do a lot of work to actually figure out what's going wrong. They have to consult a bunch of different internal databases, look across different systems to figure out why did this order get stuck, right? And it's a very time consuming and tedious process for them. They usually have to go through 5 or 6 different systems. They have like a ton of tabs open. So what we do is we bring all that data into one place and give them a really, really fast and easy to use interface that allows them to quickly sort of debug these customer issues.
Yeah, I know what you mean. It's kind of interesting because I used to work when I worked in a bank, my job was actually making this like dashboard where we had to assemble all this information, and it's such a
Yeah,
pain. But actually
totally.
for that job, I think mostly the issue was just communicating with other departments and asking them to share data rather than just aggregating the data was a problem. But still, we're building this dashboard for the CEO of the bank to just say, okay, how are we doing?
Mhm.
Because we would actually pull in investment data too, and that data has to be public. So it's like, well, how are we doing in comparison to JP Morgan, et cetera? But
Mm.
having a way that you can centralize this database, these different multiple resources into one place is very powerful, right? I think a lot of companies there's a lot of companies in that space, but of
Yeah,
course, maybe not the
absolutely.
same thing that you're doing. Because you
Yeah.
think about Mixpanel, I think Mixpanel is more into analytics and the kind of putting
Mhm.
that data together. And with Dataland, you can just do whatever, right? You can put in all different data sources. I saw in your video on your homepage, you have like Postgres on there. On
Mhm.
YouTube, I saw a video about you using what's it called?
Snowflake, I think it
Fire.
was.
I saw Firebase actually.
Oh yeah. Okay, cool. Yep. Firebase, Snowflake, basically all the different, data warehouses and databases. We supported MySQL, Databricks, BigQuery, and we support a lot of APIs as well, things like Stripe, things like Salesforce, HubSpot, all the things that a customer support agent might need to consult in the process of debugging a customer issue, right? And sometimes we'll actually even need to build specialized connectors, like you're talking about with banks. They might have some crazy old school thing which barely has an API, right? And so we actually did sometimes build like custom FTP integrators for some of these systems. So
Yeah, I mean, and that's why I think Dataland could be quite powerful because you're really agnostic about the data sources, right? I don't know, is
totally.
there a limit on which data sources you support, or it's just there's just like a common like interface that as long as you can make some glue between this connection and your data source, then we can do it. Is that how it is?
Yeah, it's pretty. I think we tend to focus on structured data. So if you have a bunch of big video files somewhere, like it's not something that we currently support today. Um, uh, but I think within the world of structured data, whether it's APIs or databases, we support basically like anything we support basically anything, and depending on the customer, we'll work with them to if we don't support it yet, we'll sort of very very quickly build one out for them. We have like a framework for sort of building new plugins or new connectors, and it's
Okay.
very very easy for us to sort of build a new one. So.
What are some of the newer data sources you started to integrate with? Like
Yeah,
the newest connectors, not necessarily the newest when those databases came out or whatever.
yeah, for sure. I think one of the new ones that we built out recently was the HubSpot connector. So one of our customers wanted to see, in addition to sort of all the internal customer data, they wanted to see sort of um, all the Hubs like they use sort of HubSpot as a CRM, so their sales team used it for all of the interactions they had with their customers before they closed that customer. And they wanted that context when they were resolving a customer issue, and like what is the value of this customer contract, right? And that might be a valuable thing because you want to know how much time you spend resolving this customer issue. If the contract value is very high, then you should really work with this customer to resolve their issues. They wanted to see that information alongside all of the internal data that they had about the customer. So HubSpot, I think, is the most recent one that we built.
Interesting. I'm also kind of curious too because what's bound to happen is that these different data sources may not expose all the things that you need.
Hmm.
So has there ever been a problem where you're saying like, okay, we can support this data source, but it's going to have a limit on XYZ? I mean, like for instance, like Firestore, I think it's mostly like a MongoDB type kind of database. So there's like certain types which are not, really clear. And then also there's things like
Yeah,
Postgres, which you can start making up all kinds of data types. And it's like, all right, well, we
yeah,
don't really know what is a duration. I'm just throwing a random one out there, right? So,
yeah,
I
yeah, yeah.
mean, so these kind of problems do happen, right?
They do. That's right. And I think I mean, we can get there's like the devil's in the details, and there's all kinds of details here, but like I think our general approach there is just on a customer by customer basis. Like generally, if there's a data type in that case, like in Postgres, like you said, you can construct an arbitrary custom data type, right? And we won't necessarily have support for that out of the box. And if we don't, then we'll just ignore any data types initially that we don't know about. And if they want us to support it, we would be happy to, depending on the customer contract. So
This is just curious from a business standpoint, right? Are you
yeah,
ever like saying, okay, we can support this thing, but we need for you to help contribute for the, development costs? Or you just say, okay, we really value your business. I guess it's probably a case by case basis, right?
yeah, it's a case by case basis. I think almost
Right.
always we will, if it's like currently it's sort of the framework for building new connectors is not something that's very self-service. So I think when for building new connectors to new data sources, it's typically something that we would have to support in-house, just because of the way that like the current limitations in our product. But a place where we will ask them to lean in a lot sometimes is on helping us define like what is that end view that the customer support team actually needs to see, right? Because they'll have a lot of our customers have like they'll have like 20 different data sources, and then and one of these, and in a single data source like a Snowflake, they'll have literally like 3,000 tables, right? And so like we don't ahead of time just automatically know like, okay, like which one of these, and then their Postgres might have another couple hundred tables, right? And we don't just like know ahead of time, okay, like here is the exact information the customer support team needs to see in order to resolve a customer issue. So once we've pulled the data in, we might ask them to work with us in building out those sort of views to actually show the customer support team. So that's typically like where we would ask them to lean in. So
Yeah, I remembered about, sorry, you keep bringing about customer support. And
yeah.
I remember you mentioned this a while ago. Obviously, keep mentioning it right now.
Hmm.
When I saw your video, I was not even thinking about customer support. I was just
Yeah.
thinking like, wow, having this stuff just for inside people to really understand what's going on, that's pretty valuable, right? Is it strictly that no, we just only care about customer support, or is it that
Yeah. Yeah.
that's front and foremost, and then other stuff is stuff that's also useful, but that's really not what we're focusing on?
Yeah, no, that's a really great question, and something that like I think throughout the course of building this business, something that we've actually internally struggled with is like, hey, like what exactly, do we kind of try to serve everything, or do we focus on one thing? And I think, um, and what's really interesting is like I think that if you look at most of our existing customers, they actually do use it across a whole bunch of different use cases. It tends to start in the customer support team, but like you said, hey, once all your customer data is in this sort of centralized unified data model, a bunch of other business units will want to use it, right? Um, like in many cases, like an operations team will want to use it, or a customer success team will want to use it, or maybe even execs will want to use it to look at aggregated views like you were talking about with your banking example. So we do find that it starts to spread out, but I think for the purposes of communicating what we do, we need to have like a focused starting point. So I think customer support tends to be sort of where we start off, and it tends to be where the problem is most painful because you have to you have to think like these customer support reps basically they have to handle hundreds of these cases per day, right? And they have to and for each of these cases they're digging through like 5 or 6 different systems right now to stitch together that full customer information. And so that problem, like, that data sort of fragmentation problem is especially acute and painful for that team. I think more so than almost any other function in most companies. So that's why we tend to focus on it as a starting point.
Now I have to kind of go back a bit more because this problem is central to your, your company, right?
Yeah.
So was one of you working in customer support, or how did this
No,
kind of
no.
problem become like a big focus?
Yeah, yeah. It's actually me and my co-founder used to work for this company called Palantir. And Palantir is like a tech company that specializes in like data integration. But Palantir works with these, these really, really big customers, whether it's the US government or whether it's these really, really, really big like Fortune 100 companies. Personally, I worked with companies like Airbus, like Fiat Chrysler, like BP. So I think so we had that understanding, I think, coming in when when we decided, hey, we're young, we're in our 20s, we want to do a startup. I think we had the understanding that like, look, like data integration is a very underrated problem, right? Like for a lot of these companies, I think you understand as well with your having experienced that banking problem, but like this most companies have, even when they're not so big, have a, a big fragmentation of different data sources, and that leads to sort of very inefficient workflows for day to day for customer support teams. And but I think especially for customer support teams, but when we're working at Palantir, for all kinds of teams, like it could be like auto workers working on the factory floor in Detroit building cars. Like it's data fragmentation was even a big problem for them. So I think this idea of bringing together all the necessary data that you need into like one centralized place so that you can just quickly get your job done is something that sort of like we really sort of the Palantir really trained into our brains. And so when we left Palantir and we're like, hey, we should, we want to, we're in our 20s, want to do a startup, like, who can we go and really, really help? I think that, that sort of, that was sort of the starting point for how we decided to, okay, let's build sort of a data consolidation system for customer support teams.
Okay, that makes sense. Now I guess the next step is that what you told me offline is when you start working on this project, I believe you must have chosen Rust from the beginning.
Yeah.
You
Yeah.
also didn't really know Rust as well, or so well, I
No,
mean.
no.
So
That's
can you
right.
talk about like, because that's a pretty risky business decision.
It is.
Even
Yeah.
when developers are starting new projects, we don't always choose a new technology for a very important business idea, right? So do you mind to kind of expand more about how you came to this conclusion, and what was the process along the way?
Yeah. Yeah. Absolutely. And I think the background is that like while yeah I didn't know Russ coming into start founding the company, but growing up I've sort of programmed like my whole life, and I have written a ton of C and C++ code throughout high school. I was on this robotics team, and throughout college I was sort of did a lot of like low level systems programming. I was like a TA for the operating systems class. Well, took a bunch of like systems classes, graduate level systems classes. So I had a ton of experience with like low level systems programming, but had really only written like mostly C and bits of C++ just as a necessary evil every once in a while. Uh, uh, so I think I had that background of like like systems programming, right? And when we're starting this company, I think what we, as you pointed out earlier, there's a ton of companies in this space, and so what really would make us unique. And I think a big focal point that we had was like, hey, can we build sort of the highest performance application possible, right? And this kind of speaks to and we knew this because having worked at Palantir, like we were, which is a big sort of um I think nowadays these bits of they use Rust in various subsystems as well, but it was a big Java shop, and we actually found that there were times when like Java, the language itself was a bottleneck, and it sort of didn't give us a level of control we needed. And and also I think we just knew that if we wanted to really differentiate by being sort of the highest performance, customer support application possible, we wanted to have, to be able to go all the way down, right, to the metal, if we needed to. And so we knew we had to pick a language that would allow us to do that. Now, having written a lot of C and C++, what I also knew was that like it's basically impossible to write like, bug-free C and C++, right? You basically have to write the first version, get a ton of segfaults, do a bunch of GDB, and then realize, oh, okay, cool. Here's like all the memory issues that I messed up, and then after a couple of iterations of that, you might have something that you can ship, and then that code might be sitting there for a while. But especially if you're collaborating on a large team with a bunch of other teammates, it's like they might not actually understand. Like the compiler isn't really helping you, right? So they'll come in, they'll make a change, not understanding. Here is the expectations of the memory management around this piece of data, right? And they'll make a change, and they'll again have to go through all these cycles of introducing bugs, debug, until they can ship something. So I think the promise that Rust had was like, okay, it was a language that would allow us to go down to the systems level, which we did have experience with and we felt comfortable with, but would also but because of the things like the borrow checker, you could actually just write code that's correct the first time, right? Which is nearly impossible for a sufficiently complex C and C++ application. And part of what gave us, so it was definitely a bit of a risk, but we did see companies like Amazon adopt it, like companies like Google adopt it for Fuchsia. So I think we did know that it wasn't we weren't sort of alone out there, So I think that that gave us some level of confidence, some level of de-risking, and I think I think part of also what gave us confidence in it was just like when we started learning it, the community was so amazing. It's like there. I think nowadays it's even more amazing. But a couple years ago when we started the company, there was already the Rust book was like everyone's like, hey, this is the go-to resource. Just go read this book and you'll know what to do, right? And like I think there's an official Rust Discord channel, right, where literally like core contributors to the compiler can help you if you are running into some weird like borrow checking issue, right? And people are just so like helpful and enthusiastic. And as we started on that, I think, if we had decided to go on that journey and then it was a really painful uphill battle for us to like learn it, I think we might have turned around and gone with something else like a Go or maybe even a C or C++. But I think it was a very smooth sort of learning path for us. So I think that just kept on giving us more and more confidence as we invested further.
I'm just guessing, but whenever I look up stuff about Go, I always see like the top issues is how to tweak the garbage collector, and so like I was just thinking like if you did go with Go, that could be really tricky, because I'm not too sure when that garbage collector will kick in.
Yeah.
So having all this data, in memory, and then you flush it and you got to put it like I don't know how that would actually be. That's got to be not the great performance. I mean, I'm aware of at least one database that started writing their database in Go. And then once they switched to Rust, it was like, wow, like a lot of our issues went away. And I'm just talking about memory size. Like
Totally. Absolutely.
It's very tricky. Performance alone,
Yeah.
is nuts. Which is really kind of weird because I think Rob Pike, I think one of the creators of C is worked on Go. So I really love to hear, like what kind of stuff he worked on and what was his thoughts, because C and Go to me they're solving different problems or different times.
Yeah.
Nowadays they solve different things. So just curious what's in their mind about why garbage collector. But yeah, sorry, go ahead.
Yeah. So to be clear, I haven't I've written toy Go programs. I haven't written very large Go programs. So I can't really speak too much to it. I was just saying like if we decide to go with Rust and it turned out to be a bad decision, I think we would have sought alternatives, and like Go would have been one of the contenders, I think, just because it is known as like a pretty performant language that does give you decent amount of control. um like, but we didn't end up taking that path, right? Because the Rust community was so great and it turned out to be a good decision. um you know like uh just even like the crates ecosystem is there's so many people who just like deeply love the link. I mean, honestly, it's funny because people like to dunk on the Rust community sometimes for this, right? If you go on Twitter, people like to make fun of how enthusiastic Rust programmers are about Rust, which I've always found kind of funny because it's like, no, like, that's a good thing, right? It's like these people they're so enthusiastic that they're willing to help other people, right, who are trying to learn the language. They're so enthusiastic that they're willing to write really high quality crates and maintain them for years and years and years, right, without getting paid at all, and they're willing to write blogs about like some design pattern, or they're willing to make PRs the Rust book to continue to make it better, or they're willing to give talks. So I think it's a really big superpower of Rust that that community is so good, just even beyond just the intellectually like why the language is great. So I think uh, so I think more than anything else, that's what kind of sold us as we started to invest into it, and we didn't have to seek out alternatives because of that.
I mean, okay, that's good. I was just kind of curious. Was there what was the point where you're like, because I mean, obviously you're starting off, there's a lot of unknowns, but
Yeah,
at what
yeah,
point did you reach where you're like, okay, I chose the right language. This makes sense. Things are actually going smooth. Do you know
yeah,
approximately when that was?
for sure. I think I think we're familiar. I like it sounds like it's a bit of like this really big decision that we made, and like it's like, oh no, what if we made the wrong decision? But the reality is like we live in the age of microservices, and if we ever thought like, oh crap, like this function, like we wrote this little bit in Rust and it turned out to be wrong, it would have been pretty easy for us to start writing new functionality in a different microservice, right? And then slowly migrate the functionality over. So I think it was never, I don't think we ever saw it as like, oh no, like this is like a, sort of one way door decision. And if it was wrong, then the whole company is screwed. I think it was like, hey, this is a bet with, where the potential upside is really high, right? Where we can sort of get really, really high performance code. And what that translates to is a really great user experience for our end users, without all the inherent bugginess that comes with like C and C++, right? So I think so that that was a bet we were taking. But yeah, like what was the point that we felt really confident? Um, it's funny because I feel like there's multiple bumps along the way. I think like as someone who's had a lot of systems programming experience, like when I was reading the Rust book, it felt great actually. Like it made a lot of sense. A lot of the patterns that Rust tries to that Rust tries to codify in the language is stuff that the C and C++ community wants, sort of generally recommends anyways, right? Like nowadays with like things like smart pointers, they like this idea of like ownership, and this idea that like, hey, maybe multiple people shouldn't be mutably touching one piece of memory at once without any idea of who's moving what around, right? Like I think these are ideas that like if you've spent enough time in C and C++ world, like are already familiar to you, and the fact that the compiler is giving you that guarantee, I think it just makes sense. So I think when I was reading the Rust book, I was just nodding my head the whole time, and I think other things, like I also have a pretty good background in functional programming, so seeing things like algebraic data types in the form of enums, like, and being able to match against very complex enums, like that just made a ton of sense to me. So I felt pretty comfortable as I was reading the book, and as we started initially writing the apps. I think one hurdle we hit was when we started learning about async, which I think is not something that you can really avoid these days. And you read the Rust book and there's like nothing about async, right? It's like, and then you're like, okay, this all makes sense. And then you're like, okay, cool. Now I need to go write like a server in Rust, like an API. And immediately you're like, okay, all of my options involve async. So now I have to learn about this thing. And was and I think like that is something where there was a lot of foreign ideas to us. There was a lot of like you have to learn about things like runtimes and executors and wakers and vtables and cooperative multitasking, pinning, right? These sort of unnameable types that get generated, which are futures, like things like cancel safety. There's all these things that you have to learn about, which are somewhat unique. You can take someone who's has a great background in systems programming. You put them into the Rust ecosystem, and you say, "Hey, go learn async." It'll take them like it'll like just reading the Rust book. They'll get through that quickly, and then I think my memory was like I read the entire Rust book in like 3 or 4 days. Made total sense to me. Was able to sort of be productive pretty quickly after that, with minor amounts of getting used to the borrow checker. And then I think I spent like maybe like 3 or 4 more weeks before I was fully comfortable with the async world, right? So I think so it took me. So it's almost like there's like this really complex second language that you have to learn, which is actually much more complex than the core language. That took me like 3 or 4 times longer to learn. So I think that gave me a bit of pause. But I think after like, I really sort of understood all of those concepts and, just ended up writing a lot more code essentially. I think maybe took about 6 to 8 weeks. I think we felt like, okay, cool. We have a good handle on this. If issues come up, we know how to debug it. If performance issues come up, we know how to debug it, etc. So.
Oh, now that you say that, I mean, has there been any, performance issues or other kinds of issues that have come up? Or because I generally hear, hey, just write it once,
Yeah.
see how it goes, and then tweak it if you need to. But usually you don't always need to do the latter. I mean, it depends on your use case.
Yeah, for sure. I think that I mean, I think generally Rust has great performance out of the box. But I think with async there were some I think there were places where we kind of shot ourselves a little bit before we sort of really knew what we were doing with things like we would accidentally, and it wouldn't even be obvious. I think in the back of our heads we knew like, okay, don't block a future for a long time, right? Like, don't just like have a bunch of code. I think the general guidance is like it should be under 50 microseconds or something. But it's not 100% obvious all the time. Sometimes you're like, okay, cool, I'm going to map over this big vec, right? And then it turns out that just to allocate the destination vector that takes time. And then as soon as that happens, you start to notice, and if that operation happens often enough, you'll see your tail latencies come up, and you're like, oh gosh, like why are my tail latencies coming up, right? It's because all your executor threads are executing this synchronous operation, and because the assumption is that it's cooperative, they can make progress on other tasks, even if they're small, right? So then your tail latencies come up, and it's actually not super easy to debug, right? Because you're like, oh, well, something is blocking the executor. Like, what is blocking the executor, right? So I think initially we actually did have, and over time we have had some of these issues pop up, and that we've had to debug a little bit. So. And this is again something else that I think async makes it tough, because if you just had a standardized, first of all, if you're just using like a thread pool, because the operating system can preempt your threads, like you don't really have to worry about this as much, right? You just write code. If it takes a long time, that's fine. That's how long it takes. It won't starve other threads, right? Because the OS will just context switch that thread out, and then like put a different thread onto the CPU core, right? But Tokyo can't do that, and if you during the debugging workflow, there's lots of tools that allow you to debug threads, right? You can use things like profilers, which usually give you a per thread breakdown. You can just see like, okay, cool, this thread spent a lot of time here, and and these tools are sort of very mature. They're not even unique to Rust. They are general purpose profiling tools that anyone can use across any language, because they work at the OS level, but I think the level of maturity, if you're trying to debug, like, okay, why is my Tokyo executor stalling? There isn't sort of like, you can't just like use like an out of the box thread profiler that would give you that level of insight into into where it's spending all that time, right? It won't just say, oh, it's that task. That's the task. This piece of code, that's what's blocking the executor. That's what's driving up the tail latency.
And well, this all remind me of another kind of subject I want to get into is, Rust is a very, young language compared to others that you've mentioned.
Yeah, for sure.
And a language is pretty much only as good as ecosystem, which, we can't deny that Rust has a really great, people around it, but it doesn't help for, very specific industries, niches that, like something like you're in, data intensive applications. So we do know that people are using Rust to build databases, but then in order to work with data, whether it's in a database or not, I'm not too sure exactly about databases, but in general, like, uh, how has it been in terms of the support for like, data?
Yeah,
Because I know you're working a little bit with Arrow and some other kind of, data related libraries. Are
yeah,
those things fully featured enough for you to actually get things going? Did you have to commit a lot of work to them? Or, what's the status?
for sure. Yeah. Um, I think that I think I mean there's a million things I would love to would love to dive into there, but I think my quick answer is like I think that like even though Rust is young, I think because the community is so vibrant and because of things like Craze.io and Cargo, there's actually an enormous amount of ecosystem. Like I would argue like, it's easier to reuse existing code in Rust than it is to reuse existing code in C or C++, even though obviously C and C++ have been out for a very, very long time. But because there isn't sort of this one go-to thing that is Cargo and Craze.io, right? I think it makes like in some ways the ecosystem is actually not as good as Rust, where you're just like, okay, cool, I'm going to add one line my cargo.toml and get all this functionality, right? And then from the library maintainers perspective, they're like knowing that so many people can so easily make use of their work also incentivizes them to publish these reusable pieces of functionality. So yeah, I think so one example of this is exactly like the arrow crate in Rust, right? The arrow crate in Rust is actually really good and really fully featured. There and it's actually there is a C++ library as well. That's like the sort of the core arrow implementation. But I think there's actually nothing that we've sorely missed in the Rust implementation. I think our team actually has had to make a couple of PRs. So we started off using this. There's sort of two competing crates. There's like Arrow 2 and Arrow, and we've had to make PRs to both of them over time to get certain pieces of functionality that we needed. But I wouldn't be surprised if we were a C++ shop and we used the core C++ library, we would have had to do the same thing. So yeah, I think generally speaking, I think using Rust for a data intensive system has been a really great experience, and the ecosystem has really supported that. So
Yeah, well, and also what comes to mind too is we are when I say we, I mean the Rust community is starting to kind of
yeah,
pioneer stuff in data science in terms of like polars is probably a pretty big one. I mean, sure, no NumPy, but or pandas even. Don't ask me the difference between the two because I never really worked with either one. But I know they're in the data sciencey land, right?
yeah,
But
yeah,
polars is also there, and I know that it does have time. It does need time to catch up, but it's gaining a lot of attention. And the funny thing about polars is like if you go to their website, I'm not sure if it's changed since I last talked to the creator,
hmm
but like almost all their examples are all using Python, which is kind of interesting. It's like, well,
yeah,
you know, it's a little bit weird, but at the same time, like makes sense because usually you're gonna be writing a lot of code, and Rust is it's not great for prototyping because you have to make sure everything works. The borrow checker is going to be there to make sure it's working properly, so you can't really test stuff. You have to really write a proper program and handle everything
yeah, yeah,
to a certain
yeah.
extent. So
For sure, if we do data science stuff all the time, and we love Python for that, we would never, I think we would never use directly use Rust. We might go through Polars. Yeah, no, Polars is a great example. It's I want to say Polars might be catching up to Pandas. Like I feel like when I talk to people, like people just love Polars, right? Because it's so much faster than Pandas. Like there's workloads where like sometimes it's like 100 times faster, right? Um, so I think, uh, And if you actually look in if you actually look in the polars, polar is very interesting because it shares a lot of the same technology that we use. Like we use Arrow. Polars also internally uses Arrow as sort of their core data representation format. And part of the reason is because it's easy for other languages to, like Python, to share that same piece of memory because it's sort of like a cross-language unified memory representation format with zero copy. And if you look in polars, like we use Rayon a ton for doing parallelization. I think they basically use Rayon as their key way of parallelizing work across multiple CPUs. Um, we I think the polars team was actually some of the first people to they were actually the people to build that other Arrow crate. I was talking about the Arrow 2 crate, which I think now actually has merged into polars, and some of the pieces of functionality of that crate, which was missing from the original Arrow crate, has also merged into the Arrow crate. So it kind of got split into half into the polars core repo and half into the Arrow RS repo. But yeah, love polars, and I think it's a great example of how Rust can be really great for data intensive applications. I think another library I'd love to shout out, and I think people don't talk about a lot, is this library called Archive. It's spelled Archive, RKYV. It's sort of another zero copy library for Rust. You can basically take any Rust struct. It can be pretty complex. It can have hash maps or B tree maps or vex, enums, whatever, right? And then you can slap a archive. It's got you can slap basically like a derive on it, just like you do with 30, and it gives you sort of it gives you essentially a zero copy serialization format for that struct, right? So essentially what you can do is build a struct, serialize it, write it to a file, right? And then you can like memory map that file, and then you can, like, without doing any sort of data manipulation, you can just view those bytes in that file as an instance of that struct, basically. And you can use that with zero sort of intermediate transformations. So the idea of zero copy, which makes Arrow so fast, but like Archive kind of makes it work for any Rust struct, right? So we use Archive a ton as well for like indexing data structures, for certain data structures we need to send over the network that gets sent over a ton, where we can't afford to spend CPU cycles doing serialization and deserialization. We can just take those bytes, immediately view them as an instance of that struct, immediately read into some offset, do some logic, and it's a really, really great library that I think is a bit under talked about. So,
Do you feel there's any sections that you ran into within Rust that you think is I wouldn't say underrepresented, but I guess would be, not as much support in like libraries and things like that you wish there was?
uh, yeah, I think. Let's see. I think that. I mean, I don't know if this is a direct answer to your question, but I think that one place that we've seen a lot, that where I think Rust can the ecosystem can generally be more aware of or be better at, is sort of um, giving the application control over memory allocation. So you'll see a lot of libraries like just return big allocations to you, right? So you call some function, and they'll go do a bunch of work, allocate a bunch of memory, and return that to you, right? Like a very simple example of this is actually the to lowercase function for strings, right? So you'll see that you can take a string, and if you just call to lowercase to it, what it'll do is it'll actually just allocate a new string, and I think that makes a ton of sense. As sort of it's really easy to use. That's the default. But if you're trying to lowercase a ton of strings, like we do in some parts of our application, like each of those two lowercase calls is gonna reach out and basically call it and do a malloc, right? And actually, like the time it takes to do those mallocs is way, way, way larger than it takes to actually just do the lowercasing, like the task of lowercasing, some UTF-8 bytes, right? Which like the compiler can do using like SIMD, and it can be super super fast. I think like if you were to just do it like manually, you can get something like 20, like you can get close to the memory bandwidth on your computer. Like how fast can you go from main memory into your CPU cores if you were to just do nothing with it at all? You can get close to that level of performance if you were to just lowercase using SIMD. And the compiler will automatically generate the SIMD code if you just write it sort of naively. Um, but because it's actually doing that allocation, that actually makes it like much slower, like on the order of like 20 times slower, right? So the throughput goes from something like 20, you can reach throughputs like 26, 30 gigs per second, goes down to like 1 to 2 gigs per second if just because they're doing that allocation. So I think that's an easy example where like, okay, cool, that's fine. It's easy to take the slice that like a stir slice, and basically just call it like lowercase each character into some existing buff, right? And then some pre-allocated buff, and you're not at that point, you're no longer calling all those mallocs. So that one's easy. But sometimes a library has a lot of functionality, right? And you call into it, it has a ton of allocations. You have no control over those allocations. And if you need that functionality in some sort of like hot-ish loop, then you essentially have no alternative other than to just rewrite the functionality yourself, right? You just can't use a library, basically.
Yeah, I definitely know a couple of. Well, I met one guy. I think it's MakePad, the creator of MakePad, which I'm not too sure if you've looked at or not, because they have a wicked fast like GUI that I'm trying to get him to come on the show. Have you seen his thing or no?
Yeah, I have seen it. It's cool. It's cool.
It's I he claimed it can compile like super fast. He showed it to me and I was like, wow, that's really crazy. And it's like still in develop mode or production. It's like half a second or something, and because he's got like basically almost zero dependencies, which I mean it does take a lot to to do something.
Yeah,
But
yeah,
as you just said, like if you really need it or you want it, you can do it. It's just a pain to do. He was
totally,
working on MakePad for like years at least, which
totally. Yeah. And like the places where we really need that optimization, we can't, we know how to go down and do it ourselves. But I think if there was just a little bit more awareness in general, I think a good example of a language that I think Rust can learn from is Zig, right? Where it basically forces every function that allocates memory, you pass an allocator into, right? So it's very clear who's allocating memory. It's very clear, what allocator they're using. If I only need the memory to exist for a fixed lifetime, I can pass in a bump allocator. And even if it's doing allocations, then it's not doing a general purpose malloc. It's just doing a bunch of bump allocations. It's just bumping like a pointer up, right? So it's way faster than calling a general purpose malloc. And Zig really gives you a level of control. And this is something that I think the Rust team is working on. There's like this global allocator thing that's in a nightly, that's in nightly, but I don't think there's any plan there. I don't think, as far as I know, there's no plans to stabilize in the coming. There's sort of no concrete plans to stabilize it. So I think, uh, yeah. So I think part of it is just like if there's just more general awareness from library authors, that would be great. I think that if and I think if the language goes even further and allows sort of uh, control over which allocator is being called, I think that'd be even better.
yeah. But I mean it does come down to like you know I have this discussion with another developer in another language, but it's always like time versus output kind of thing, and the benefit that you get out of that, right? So I'm guessing that if it's a performance problem, they just don't have that issue, or else they would have spent time to try to optimize it. And if nobody's really complaining or giving a value use case or whatever, and they just don't see it as a big deal, which I mean makes sense. Like computers are super fast compared to a long time ago.
Yeah,
But I mean, if you're handling lots of data and you need stuff to be quick, then you have a different need than the guy who just needs to solve his problem and then he's done. Where time is not the amount of time it takes right now is not a concern, right?
yeah. No, I think look, in most cases it's not an issue.
Yeah.
Um, But I mean, again, just to illustrate how pervasive this is, it's like if you like the most common thing that you'll see in Rust is you'll have structs with strings in it, and you'll slap a Serde serialize deserialize on it onto it, right, to get JSON a way to get JSON representations of that struct. And if you were to, let's say you have a server which is deserializing a ton of these structs, right, or really big structs, like every time there's a string embedded in there, like I think what and I think people realize this, but it's like that is calling malloc over and over and over again, right? And if you look at actually these, this is a good example where maybe like Rust is lagging behind some of the more mature C and C++ alternatives. If you look at the Google protobuf crate, the Google protobuf library, not crate, they actually have really good support for, because like what Google noticed was that if you look across, all these Google services which are deserializing protobufs, right? Initially, they were doing the same thing. They were deserializing into like a std string in C and C++. But what was happening was across all of Google services, that was causing a tremendous amount of memory fragmentation. Because, these services, like literally they like billions of times a sec, like, across this fleet of services, it's just doing an insane amount of small allocations, right? Small weird size allocations of these strings. And then it would free it, and then a new set of structs would come in. They might have slightly different size strings, so then the allocator can't necessarily reuse those exact slots that it allocated. And then so they were noticing such memory fragmentation that if you look at the protobuf C and C++ implementation, they have really good support for passing in like an arena, right, or like a bump allocator that prevents that memory fragmentation. It's just like, okay, cool, like allocate all these structs into this big vec U8 essentially, right? And when I'm done, I'll just drop the whole thing, and then I can just reuse that vec U8 for the next batch, right? And I'm not sort of individually calling out to the general purpose allocator to allocate all these tiny little allocations, which causes fragmentation. So yeah, I do think over time, as people, to your point, like as people notice this more, and it will be just something that is prioritized. But I think, yeah, it's a work in progress, like all things. So
yeah, totally, I understand.
Yeah.
Yeah, I think we're starting to approach kind of the end of our recording time. And I think I've also covered like a lot of stuff in here, and it's great to hear some feedback, because I feel like it's good that you start from like an actual practical problem, and then you're trying to find a technical solution for that, because not everybody starts like that. Some people, they start from the technical thing and then try to find something to do with it.
I love that too, yeah, either way.
So I mean, is there a point is there somewhere that we didn't cover while we recorded, or did you say everything that you wanted to say, or is there something else?
I mean, maybe briefly we can touch on the if we have time, we can touch on the front end stuff.
Oh yeah, for sure. Yeah, you're using a lot of WASM, right?
Yeah. No, which is why I know about MakePad, like which that you mentioned, because I think we take a similar approach. So we, so like again, the one of our key goals with Dataland is to make it a really, really, really great and seamless and fast user experience for these customer support reps who literally have to do these operations hundreds of times per day, right? Like that's the real human problem we're solving. And so we wanted to make the UI really fast. And like part of what and so like we actually use Rust on the front end. So like when we send data, so the parts of our UI which are very data intensive, like we have this really big, I think you probably watched our demo video, like we have this big table view, right, that can support like billions of rows, that can load instantly in your browser, and you can scroll through the whole thing and it's totally seamless, right? And you can like search over the whole thing. You can just like do arbitrary free text search over billions of rows, hundreds of gigabytes of data, and sort of like instantaneous with sort of under 50 millisecond latency. So I think those are some of the UI that's sort of like that So we were sort of motivated to think about how we can push UI performance in the browser sort of as far as they can possibly go. And so some of the ideas we talked about earlier like feeds into this, which is like using Arrow, right? It's like we actually just send like basically chunks of the table to the front end using Arrow with sort of zero intermediate data transformations. We don't convert it into JSON and then like send the JSON over, and then on the other side, you do like a JSON.deserialize to get some JavaScript representation. Like that doesn't happen, right? Like we take bytes, which are like living in memory on one of our data nodes, and it basically goes straight, gets copied directly onto the wire, like the arrow bytes that goes directly into some like the memory of a WebAssembly module. And then we actually just render that directly out of those arrow bytes into pixels on the screen using using WebGL. So I think that and like the reason we're able to like there, I think you could conceivably use JavaScript to do that, where it's like, okay, like there is a JavaScript arrow library, and you can make the WebGL calls in JavaScript, but it's something that we actually use Rust in the browser in WebAssembly, and we're able to sort of reuse a lot of the same code that we use on the back end when working with Arrow, for example, and we're working with like text in Arrow to do this rendering. So that's been really interesting. And one thing that we do there is, so most, if you actually go and look at so Megpad doesn't do this, which is why it's so fast. But if you actually go look at most WebAssembly Rust applications, what you'll see is they will actually not directly use WebGL to render to the browser. They will actually still go through the DOM, right? So the WebAssembly code will actually make calls out to the JavaScript environment. So it will, which will do things like manipulate, just like React or whatever. Like they will like manipulate the DOM to render things onto the screen that the user can see, right? But that actually adds a lot of like that crossing of the boundary from a WebAssembly module into JavaScript in the DOM actually causes a lot of overhead. It's actually more overhead than if you were to just use JavaScript, because, for example, every time you were Rust strings are UTF-8, JavaScript strings are UTF-16. So every time you pass any sort of string data, automatically you need to do sort of this linear path conversion, right? Every string, and then you also incur all the overhead of the DOM. So you can't sort of get that really seamless panning experience and scrolling experience that you can get with the approach that we take. But because of this, we have to use actually because we're trying to do things like render text using WebGL, we actually have to interface a lot of C libraries using FFI. So we have to use things like harfbuzz to shape text, and we have to use things like Skia to actually take the shaped glyphs and actually render them onto like WebGL surfaces. So I think you mentioned that your company uses Flutter, but which also actually uses Skia under the hood. So that's an interesting point of overlap. But yeah, so so Skia is a C library that we FFI against. Harfbuzz is a C library that we FFI against. And there basically just are not good pure Rust alternatives for some of these libraries, because they're so mature. Like there is no getting away from harfbuzz, right? If you want to shape text, there's just no alternatives. And rebuilding Skia yourself would be also immensely painful, right? Although I think the Makepad guy has done a great job of rebuilding some of it in Rust. And so yeah, that's been a really, really interesting experience as well. Just doing a ton of not just using Rust in WebAssembly, which I think a lot of people do, but using Rust with fully a full sort of using Rust with WebAssembly and rendering without going through the DOM, I think is somewhat unique. There's a couple of other people out there doing it with like Makepad, but I think it's something that is a pretty interesting experience that we've had to deal with, and definitely had some paper cuts along the way. So
yeah, that's a good point, and that's something I know that there's always this like, sometimes as you said, Rust people are very kind of very happy about using Rust and want people to also give it a try. But then sometimes we do become too crazy and we say we write it in Rust, or there's that faction of people, right? But then there's some of these libraries where it's like, yeah, you can, of course you can rewrite anything in Rust, but then it's like, well, if something's been battle tested and working, and like better just not touch it, because even if it's not Rust and it is C, and we know C can be dangerous, but
totally,
it's done and it's working, and there's no problems that we found so far. So like this one I don't and then maybe not really agree with. But then there's also stuff like we had a recording with the one of the people working on Onion, right? Sorry, Tor
Mm.
with
Yeah,
Onion,
yeah,
right?
yeah.
And like that one, I think makes sense to rewrite. There's a couple reasons why he rewrote it, and one of them for sure was definitely safety. Because you screw up with C, and then somebody could literally, die, which is really
Yeah,
crazy.
for sure. Yeah, yeah, yeah. It compromises like the Tor guarantees, right?
Exactly,
And then
right. So
your location leaks. That's really scary.
exactly, that's for sure one of the reasons, but not the only reason. There's always the famous, you add something and then kind of have spaghetti. Just like any project over time will be, you know, needs some serious retooling to make sure it's okay.
Yeah.
Um, but yeah, I mean, yeah, thanks for that insight. I totally forgot that you can just start rendering directly to the screen using WASM. I do know that there's definitely a performance when you switch between the two, between like JavaScript and that. And I didn't know it was so bad that you're saying that like it's better if you just stick with JavaScript in that case, which is
Yeah,
interesting.
yeah. I mean, look, if you're doing a lot of really heavy, if you're doing some like crazy heavy CPU algorithm, like WASM is faster than JavaScript, and so, but like if your application is primarily just doing, like if it's sort of like a standard React app almost, right, and you're just rendering some UI elements onto the screen, like there are libraries like Leptos, which is basically like a Rust React alternative, but you actually won't get. I mean, like you might see benchmarks where it's marginally faster for various reasons because you can build the reconciler a little bit faster in Rust than you can do in React, right? Um, but like the raw act of manipulating the DOM will always be slower from WASM than it is doing pure JavaScript, just because you have to cross that boundary. And every time you cross that boundary, it's effectively doing like serialization and deserialization. Um, so that yeah, so I think it's not just like WASM is faster, everyone. like it is faster if you are willing to go pretty far, like the like MakePad has or like we have. But I think for the most part, like most of the UI you'll see in Dataland is actually just TypeScript and React, and some of the really intensive pieces are in WebAssembly, and the reason is just like there's no good reason to go 100%, like at least right now, to go 100% into WebAssembly. So
All right, yeah, that's some good insights. Well, I mean, if there's nothing else, then we definitely should be ending soon because we're about to definitely hit up the time. But it was great
cool.
hearing your insights, and that's a now you gave me some more thinking about if I do have something performance wise in terms of like UI and stuff, maybe I should be looking at rendering like how you guys render. So I'll have to take a look to see how you guys do stuff. It sounds pretty interesting.
Yeah, yeah, yeah. I think a good starting point is if you go look up the Rust Skia library. They have like
Oh,
a
right.
they have like a WASM 32 unknown M script in target. That's like a great starting point.
Yeah. Yeah, well, actually, the other thing too is you'd mentioned about Flutter, right? Flutter is getting away from Skia. They have their own impeller engine now. I guess there's definitely something that Skia doesn't. It worked for a long time, right? But so
Yeah,
there's some issues they have now with the performance and stuff, so they're getting away with it. And just like I kind of said before, it's like no matter what, you're gonna reach a point where it's like, okay, this worked. Now we need something else, and we know what we need. We had experience, so we know how to write this thing.
yeah. No, it's really I didn't look into that. I also did hear about that. That's really interesting that they're switching away. But like I think generally we're pretty comfortable relying on Skia because it's the core rendering engine that powers Chrome itself, right? So I think like it's like we know that it will be maintained, and that like they will fix bugs, and fix like cross GPU incompatibilities, which are things that you would have to deal with if you were to try to build some alternative to Skia, right? It's like the same sequence of WebGL calls on different GPUs do not result in the same pixels on the screen, right? Like you have to sort of deal with really sort of dirty real world issues like that, which
Yeah.
Skia kind of has encapsulated away for you. But yeah, so I think well, yeah, Skia for the most part we're pretty happy with, and I do need to look into why Flutter switched away. I think that'll be insightful.
Yeah, I think it's about there's some performance stuff when it comes to like they keep talking about jank within iOS with
Oh,
shader
interesting.
caches warming up or something. I'm not an expert in this, but I remember that was a lot of talk for a while, and then all of a sudden I said, well, we have this new engine and it's much faster, and And now they can start to do more 3D things because even on their own
Mm.
page, Skia says we're 2D, right? And
Mm.
people are looking at using Flutter for building games, and
Okay.
we like 3D games more. I mean, we live in the 3D world. To keep working with 2D after a while is, and
Yeah.
now you have to add some 3D stuff to your websites nowadays. Web GPU is something they're also pushing, so it's
Okay.
not
That
really
makes
so surprising. Yeah,
yeah.
but
Yeah. Yeah.
cool.
Ski is pretty focused on the 2D stuff. So that
I
makes
mean,
yeah.
it's an old lib, right? It's like 2000s something,
Yeah.
2010s or something. This is quite.
Yeah. No. No.
It's,
I think this guy started working on it in 2005, and Google acquired them in 2007, and it's been
oh yeah,
at the core of Chrome ever since. And yeah, so I think there's some lines of code in there that was written like maybe 20 years ago. So that
but it worked.
yeah.
That's why it hasn't been changed.
Yeah, yeah, yeah. Absolutely. Absolutely.
Cool. Thanks for coming on. Sorry, it's
Thanks for having
frustrating.
me.
Yeah, thanks for coming on. It's great to hear.
It's an honor to be on. I religiously listen to all the episodes as they come out. So
Oh, perfect. Then you can listen to yourself, right?
no, I think I'll skip this one.
Yeah.
But
I
yeah.
used to listen to myself on here and just listen, and I was like, I don't know, you just don't really want to hear yourself after a while.
Yeah, yeah.
Okay. Again, thanks for coming on, and hopefully we'll have you guys back on again in the future.
Sounds good.